Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, in today's lesson, we are going to be dividing with decimal numbers. And this lesson's going to kind of show you, it's going to take what we've learned so far about equivalent fractions and showing how decimals and fractions are related to each other and how we can use that concept to justify what we do when we divide with decimal numbers. So let's go ahead and read the preview. Today you will review and practice working with decimals. While you might usually use a calculator when dividing decimals, it is important that you understand how decimal division works. This way, when you encounter problems that involve both decimals and variables, you'll be able to simplify expressions and manipulate the symbols correctly and efficiently. Today's problems will help you extend what you know about fraction division and make sense of why we do what we do when we do the decimal division. For today's lesson, you may only use your calculator to check answers that you have first calculated by hand or when you are specifically directed to use it. There is actually a problem where you're allowed to use the calculator. But for the most part, let's try to avoid the calculators so that you can understand this, okay? It's important to understand why we do things that we do. All right, so let's read through this question first. This is a kind of a situation where division is required. Mr. Garcia needs to cut short pieces out of a 16-foot long board to use as spacers in the wall of his new house. Okay, so any of you that have ever considered possibly going into construction or getting work, doing work as a contractor, if you talk to anybody who work in those fields, mathematics is critically important. So, it's a good line of work to get into. There are lots of jobs, but you've got to have basic understandings of mathematics for those jobs. So here's an example of a situation where you'd need to understand how to divide. So without using your calculator, how would you determine how many such spacers you would need to cut from Mr. Garcia's board? Remember, the board itself is 16 feet long, and you need the spacers to be 9 inches long. Now, as we start into this, you'll notice you've got two different units of measurements. One's feet and one is inches. In order to really get this right, you've got to convert. There's got to be a conversion. You either want to change your 9 inches to a number of feet, which happens to be 3/4 of a feet, since there are 12 inches in a foot, and 9 over 12 is the same as 3 over 4. Or you want to change the number of feet to the number of inches, and 16 times 12 is 192. So really, what you're trying to figure out is how many 3/4 foot pieces or spacers will fit into the 16-foot board, which would be 16 divided by 3/4, or how many 9-inch pieces or spacers would fit into a 192-inch board, which would be 192 divided by 9. Now, if you want to look at the visual of this, we can kind of get an idea of what that answer is going to be. Let me change this guy so it's a little bit thinner, and let me make it so it'll stand out. So I'll make it red. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 feet, right? So 16 boxes. I made each one of those boxes 1 foot. It's also 192 inches, right? Because we did the conversion up there. Well, I'm going to stick to the feet, and I can find the 3/4 mark generally, right? You got the halfway point, and you've got the 3/4 mark would be right around here, correct? And if we put 2 3/4 together, see, there's 1 3/4, and then another 3/4, that gets you up to about the halfway point, right? Let me just go ahead and try and put that in there. That's about the halfway point. So if you take another that's 1 and another another 3/4 would be right around here, and then 4 of them would get you to there. Okay, so each one of these is about, is that about right? Hold on for a second. 3/4, 3/4, 1/2, and another quarter there. Yeah, that's about right. I mean, it's kind of hard to get those perfect, but essentially every 3 feet is 4 spacers. right? Think about that with that fraction. So I'm going to go ahead and continue with this process. 3/4, 3/4, stop it, 3/4, 3/4, another set, 3/4, 3/4 puts us to the halfway point, another 3/4 puts us to the quarter point, and then here, then we've got 3/4, 3/4, doobie-doo, 3/4, 3/4. This is all working out perfectly. 3/4, not making any mistakes. 3/4. I'm almost done. 3/4. And then this guy. And then do we make it all the way across? No, we don't. There's still a little bit left over. So how many 3/4 do we have here? Hold on for a second. OCD. Got it. Okay. So how many of these do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 with a little bit left over, and that looks like it's 1/4. So that looks like it's like 1/3 of the 3/4. So I'm thinking we got 21 spacers that we can get out of this with a little bit left over. That's his spacers, by the way. Shall I rewrite it? Perfectionist spacers. Okay. So that's how we can do it visually, drawing the picture and actually physically showing all those 3/4 foot pieces that you could fit into a board that is proportionally 6 feet long, right? 16 feet long. Okay. So now let's take a look at the mathematics part that we would be doing up here. Sloan is a fraction wizard and prefers to convert all fractions in any problem, convert all numbers in any problem to fractions. But her teacher insists that she be able to do Mr. Garcia's problem with decimals as well. Sloan knows that 9 inches is the same as 3/4 of a foot, so she first wrote this problem as 16 feet divided by 3/4 of a foot as a fraction, which is a division problem, as we've discussed previously. I suppose I could use decimals. Sloan moaned. Oh, she's just so depressed at the idea of using decimals. I know the decimal equivalent for 3/4 is 0.75, so if we wrote it this way, that would be the same as 16 over 1700 or 75 hundredths. Oops, I'm back to fractions again. What do I do now? So she went to her teammates to have the discussion. So which giant one would you have to multiply by to change this fraction here to a fraction with only integers, right? 16 is an integer, but 75 hundredths is a rational number. That's technically not considered an integer. Sure, the fraction itself has integers within them, but the entire fraction is a rational number. So what giant one would you use? How would you get this guy so that it's an equivalent fraction without having integers or without having rational numbers? Well, this is what I would do. If you take 16 over 75 hundredths and you want to convert this guy so it's got 1 in the denominator, you have to multiply 75 hundredths times its reciprocal, which is 100 over 75. And if we're going to make a giant 1 over this, and we're going to make an equivalent fraction out of this, we have to multiply the 16 times 100 over 75 as well as the 75 hundredths times 100 over 75. And what you get here is 7,500 over 7,500, which is equal to 1. So what eventually happens is you end up with this as your new fraction. So 16 over 75 hundredths ends up being 1,600 over 75. Now, decide with your team or on your own if this is the same problem as that. Is 1,600 divided by 75 equivalent to 16 divided by 75 hundredths? And I think you should know that yes, that is actually correct, because we know that when you multiply a fraction times 1, or any number times 1, it's going to be equal to itself. So we've essentially just converted this into its fractional form and used the giant 1 by multiplying times the reciprocal to get us an equivalent ratio. So yes, we are. Oh, we're being multiplied by a giant. Oh, that's awesome. No, they're being multiplied times a giant 1. So it's equivalent. Okay. So let's take a look at this. What do I write? Sure, we could have also done it with it in decimal form, right? If we had left this as a decimal instead of a fraction, and we would change our giant 1, but we'd still change it by multiplying by a by a giant 1, but we would just multiply 7,500 times 100, and that would change it to 75, and 16 times 100 changes it to 1,600. So yeah, we've got two different ways in showing that this is equivalent to the original fraction, which was the original division problem. So your task is to write Sloan a letter and show the work to show how we would get our correct answer. I don't know if you really want to write a letter here, but go ahead and do the problem, show your work, and see what you get for an answer, okay? Here is the wonderful letter that I wrote. Dear Sloan, this is how you solve the problem. If you take 1,600 divided by 75, you end up getting 21 and 25 75ths, right? Because 75 goes into 160 twice, and that's 150. We do the subtraction, and we bring down the 0. How many 75s fit into 100? Only one of them. That would be 75, and when we do the subtraction, we get 25. So if we're going to just write our answer as a fraction, we can just stop right there and say, well, that's 25 over 75, which can be simplified down to 1/3, 21 and 1/3 pieces. Now, does that agree with what we had over here? Yeah, kind of. That's what I was thinking. We know 21 spacers or pieces for sure, but that 1/4 right there represents 1/3 of the 3/4 spacers. So that's how you get your 21 and 1/3. But ultimately, we would give the final answer as just 21 spacers, and then that third of a spacer just gets tossed off onto the scrap. Okay. All right. Many people have difficulty locating the decimal point in the answer to a problem like this. Use your answer to part B of problem 81. Why problem 81? I don't know what's going on there. I think this is problem number 99, whatever. Let's just solve this problem, okay? So copy down 16 divided by 0.5. And then where would we go from there? We can write that as a fraction, correct? 16 over 0.5. And we don't like having decimal numbers in our fractions, just like we don't like dividing by a decimal number. So if I multiply times 10 over 10, this giant 1, it becomes 160 divided by 5. And now we can divide this problem with very little problem at all because, you know, we don't have to worry about where the decimal point goes. We know that the decimal is going to be right here. And in this case, we don't even need the decimal places because 5 goes into 16 3 times. That's 15 with a remainder of 1. We bring down the 0, and 5 goes into 10 twice. And that's where it terminates. So our answer to 16 divided by 0.5 is equal to 32. Okay? All right, this is the problem where you're allowed to use a calculator. I want you to take some time. Take each one of these words and write it as a division problem, and then use your calculator to declare what the answer is. For instance, 3 divided by 4 can be written as the problem 3 divided by 4, which is 7500ths, because when you take 3 divided by 4, you get 0.75 7500ths. So go ahead, copy down each one of these phrases, word phrases, rewrite them as division problems, and then use the calculator to determine what the answer is. And then, what do you notice about these problems? Some of them have something in common. Others have something else in common. How are they similar and how are they different? Okay, go ahead and pause while you do this work. Take a little bit of time for that, and I'm going to pause as well. Okay, so hopefully you've got everything written in. You're able to use your calculators to figure out these. I'm just going to do the reveal for each one of them. See if you've got the same thing written out. All right, what are we noticing? You notice that this guy right there has an answer of 75 hundredths. This one here has an answer of 75 hundredths. This one right here has an answer of 75 hundredths. And this one right here has an answer of 75 hundredths. Then you look at B, that has an answer of 6. C has an answer of 6. F has an answer of 6. And H has an answer of 6. So look at what's going on with each one of these problems. Notice how the decimals have just kind of like been moved in each one of them, but the numbers themselves are the same. So what we get here is problems A, D, E, and G all are equal to 75 hundredths. They're all sort of variations of the same problem, just with giant ones moving decimals to different locations. And then problems B, C, F, and H are all equal to 6 for the same reason. Okay, so we can manipulate these. Like for instance, let's take E. If I were to write E out, I would say this is 0.003 divided by 0.004. So if I want to rewrite this with only whole numbers or only integers in our numerator and denominator, I would have to move that decimal 3 places to the right, and this one 3 places to the right. So I would have to multiply the numerator and denominator times the giant 1 with thousands in the numerator and denominator. Okay? Here, if I take 0.15 and I want to divide it by 0.025, there's actually a rule that we have to follow. You don't necessarily have to get whole numbers or integers in the numerator and denominator. You just can't have it in the denominator. In this case, if I multiply everything times 1,000, it'll take care of both of them. So this will move this 3 places to the right. We'll have to add a 0 here to move that 3 places to the right. And then we end up with a fraction or a division problem with no decimals in them. Okay? So here's a stoplight problem. Here's the mistake that students often make. Eloise wants to divide 7 hundredths by 4 tenths. And she thinks she can just take 7 divided by 4 and everything's going to be wonderful. What do you think? Does this shortcut work? Go ahead and formulate your thoughts and write down a response as to whether or not you think this is okay or whether it's not okay. And I'll give you a hint. It's a stoplight problem. So that means she's making a mistake. A common mistake that lots of people make, though. So we want to correct some misconceptions here when we address stoplight problems. Okay, so were you able to pause, formulate your thoughts, and write down a response? My response is no, she's not doing it the right way. She needs to multiply the 0.07 and the 0.4 by the same power of 10. Here, what it looks like she did is she took 0.07 and she multiplied that times 100, and then she took the 0.4 and multiplied that times 10. And that doesn't work because this is not a giant 1. So you're not getting an equivalent ratio or an equivalent fraction here. You would be getting, if you did it the right way, this would be 7/40. So this is not the same as that, okay? So now go ahead and determine how you would find your answer. And so that's where we're going to take this process right here. Oh, maybe not. Let's not do that yet. Leave that there, even though I did a bit of a reveal. Not sure if you saw that. Okay, so how would you find your answer? Well, there's one way to do it, and that would be if you just wanted to focus on getting your decimal out of the denominator, you could do that by multiplying the numerator and denominator by 10. This would be your giant 1, And it's actually okay for you to have a decimal number in your numerator in your dividend. It's your divisor that needs to be the whole number. Because when you've got the decimal here in your dividend inside the box, you just line it up with your quotient, your answer on the top, and then work your way through the process. 4 goes into 7 one time with a remainder of 3. Bring down the 0. 4 goes into 37 times. That gives you 28 and gives you a remainder of 2. So you add another 0, and 4 goes into 25 times, and that's where it terminates. So our answer appears to be 175 thousandths. Notice I did not clear out all decimals. I just made sure that I did not have a decimal number in my divisor, in my denominator. Now, you could, if you wanted to, just clear out all decimals. If we chose to multiply the numerator and denominator by 100, then I would get that 7 over 40 that I showed you up here. And now you can take 7 divided by 40 and put your decimal in, right? All you have to do is line it up with your quotient, with your answer. And now how many 40s fit into 7? 0. So we have to move to the next place, add a 0 here. How many 40s go into 70? That would be 1, and it would give you a remainder of 30. Bring down the next 0. How many 40s go into 300? That would be 7, because 7 times 40 is 280. Do the subtraction, you get 20. Add another 0 and bring it down. Remember, you just keep adding zeros and bringing them down until you either see a repeating pattern or until it terminates. And this is where it terminates. 40 goes into 200 5 times. So we get the same answer. Both of them are correct. And if you want to double check it with the calculator, 0.07 divided by 0.4, 700ths divided by 4 tenths is 175 thousandths. Okay, so that's our final answer. So this is the process that you go through. Now, do you have to write all of this? No, this is where you were taught probably in 5th or 6th grade. I'm not sure. I seem to recall there being an issue with 5th grade not teaching division, long division anymore, but I think your 5th and 6th grade teachers have tried to correct that. Remember in those lessons how you would write it as a division problem, and then however many places it takes to move this over so you've got a whole number, you move it this one the same number. That's what's happening right here. You're essentially multiplying this times 10 and this times 10 to get your decimal lined up in the appropriate location. So there is a reason why we do what we do. Now, when I was in grade school, we just did hundreds and hundreds of these problems, and our teacher said, you just do it. Just move it to the right. However many times you do it here, do the same thing here. They never explained to us the logic behind why we would need to do it and why that makes this division problem the same as this division problem, or this one the same as that one. Okay? So now that you kind of understand the correlation between our division processes and our giant ones, now hopefully it's going to make more sense and you'll remember the process for completing these division problems. Okay, so go ahead and pause after you've copied down these 3 division problems. Go ahead and rewrite them so that we're dealing with, excuse me, an integer in the denominator, and then work through the process. And I'm going to give you a hint right here. You see how that's a division problem with a negative in the numerator and a positive in the denominator? That means you are going to get a negative answer. I would highly recommend you write down the negative sign where you're going to write your answer, and then do the work with just the absolute values. And then when you get your answer, click back in there with your negative sign so you don't forget that your answer was supposed to be negative. Okay, go ahead and pause. Give it a couple minutes to work through this. Show all of your work, and then unpause when you feel like you've got all the answers and you want to see if your answers are correct. All right, let's see what we got here. 25 divided by, or I'm sorry, that's 2.5. Oh, I hope you didn't write 25 there. That is 2.5. Shooby-dooby-dooby-doo. I'm going to have to make a change. Hold on. I read that as 25 initially, but that's 2.5. Let me pause and I'll fix it and I'll come right. Okay, much better. That's supposed to be 2.5 divided by 25 hundredths. Still going to multiply times 100 over 100 because I've got to move that decimal 2 places to the right. I cannot have 25 hundredths in my divisor. So 2 places to the right, 2 places to the right makes this 250 divided by 25. And how many 25s can you fit into 250? What would you multiply times 25 to give you 250 for an answer? Well, that's 10, right? So our answer for problem A is 10. Here you've got 1 decimal place in the denominator, so we're just going to multiply this times 10 over 10 and make this negative 11.2 divided by 7. So 7 goes into 11 1 time with a remainder of 4. Bring down the 2. 7 goes into 42 6 times. That's where it terminates. So our answer ends up being not 1.6, but negative 1.6, right? And then how many places do we need to move that to the right? Looks like we could just multiply times 10 over 10. So it becomes 591 divided by 3. And I did the adding. Turns out 5 plus 9 plus 1 equals 15. So I knew I was going to get a whole number for my answer. Turns out 591 divided by 3 is 197. So 59.1 divided by 3/10 is also 197. Okay, now, as was mentioned at the beginning of this lesson, most people that I know, including myself, when you have division problems with decimals, just pull out the calculator and do the work, right? 59.1 divided by 0.3, 197, write down your answer. But it's just good for mathematical knowledge for you to understand why we do what we do. So in certain exercises, we'll ask you to show your work. When you start getting into higher levels of algebra where you have to deal with unknowns, it's not as easy to solve those using a calculator as it is just working with numerical expressions. So you will have to have a basic understanding of how the division works when you're working with algebraic expressions. Okay, so practice this, show your work, check your work with your calculator, but please do not just put these numbers into your calculator and just write down your answer and move on to the next problem. When you do that, sometimes you punch the wrong numbers into the calculator and you get the wrong answer, but then you didn't copy the work, you didn't show any of your work, and you don't understand why you got it wrong. So copying problems down and showing work is essential. Good luck on your homework. We'll, I guess, see you for the next lesson. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,